This is an example of using a Riemann sum in order to estimate the area under a curve. So what our goal is to estimate this area under the curve, y equals sine of x squared over the interval from 0 to 1. And the way we're going to do that is we're going to use 4 boxes, n equal to 4, and we're going to use what we refer to as midpoint evaluation. So, in order to start evaluating this Riemann sum, we take the interval from 0 to 1, the interval that we're finding the area over, and we partition that into n equals 4 equal pieces. So our partition will be 0, 1/4, 1/2, 3/4, and 1. So in the picture, we're dividing the interval into 4 subintervals, 4 equal pieces, which we refer to as a regular partition, into 0, 1/4, 1/2, 3/4, and 1. And the idea is to create 4 boxes that are going to estimate the area under that curve. And so that determines the width of the boxes, 4 equal pieces, whereby the delta x, the width of each of those 4 boxes, is going to be 1/4. And then what we do is we have to select a value inside each of the 4 subintervals that's going to determine where we're going to evaluate the height of the box. So what we're going to be doing now is using the midpoints. And in fact, these are going to be what we refer to as the C sub i's, meaning that we select a C for each of the 4 intervals, a C1, a C2, a C3, a C4. Thus, we refer to them as C sub I for each of the counting from 1 to 4. And the midpoints of each of these subintervals are going to be 1/8, 3/8, 5/8, and 7/8. And where those are used is we have the midpoint of the first interval is going to determine, we're going to evaluate the function sine of x squared at 1/8. And that's going to determine the height of that box. Then we're going to evaluate sine of x squared at the next midpoint, 3/8, on that curve, and that gives you the height of the second box. We do that with the third, 5/8. Gives us the height of that box. And lastly, 7/8, the height of this box. So what we have is we have 4 rectangles that we can evaluate the area, width times height, add them together, and we've got an estimate of the area. Noting that the boxes will go over a little bit and under a little bit, but overall, we figure they might be a pretty good estimate of that area, which is why midpoints are a very commonly used selection of the C values to determine your heights, that they get a fairly accurate estimate, even if you're doing with only a few boxes, such as with 4. So, let's go ahead and evaluate this estimate of that area. So that's going to be a sub 4 with 4 boxes. The common width of all of them is 1/4, so we can multiply 1/4 by all of them. And then the heights of each of the boxes are going to be the function sine of x squared evaluated at each of the midpoints. So let's go ahead and put those into the function. Remember, it's x squared, so the sine of 1/8 squared is going to be the sine of 1/64. Then we have the sine of 9/64. The sine of 5/8 squared, which is going to be 25/64. And finally, sine of 7/8 squared, which is going to be 49/64. So, with your calculator, go ahead and evaluate those 4 heights and add them together, and eventually they're all going to be multiplied by the common width for each of those. Remember to have your calculator in radian mode whenever you're finding the values of any trigonometric functions as graphs of functions. So on the calculator, you should get this. 1.2295 40473. And remember that that's the sum of the four heights. We have to multiply by the common width. So if we multiply that by 1/4, we should get this. 3073851182. Or if we were to say it around this to say 6 places, our estimate, our A4, taken to 6 places, 307385, if we want to get an estimate to 6 decimal places. Which is actually a pretty good estimate because, as it turns out, the actual area under this curve was approximately 0.3102. So even 4 boxes, we got a pretty good estimate of the true area under y equals sine of x squared over the interval from 0 to 1.